This episode was brought to you by Riverflow Pumps. This is Peter Davidson of Current Systems, and you are listening to Ask the Masters podcast.
Welcome to this episode of the Ask the Masters podcast. On this week's episode, we're sitting down with Peter from Riverflow, who is an expert on lazy rivers and swim currents. Stay tuned for a very informative show. Hello and welcome to the Ask the Masters podcast. This podcast is dedicated to discussions about the design and construction of water shapes. The hosts of the show are all certified SWD masters who represent the leading builders and designers within the water shaping industry today. All right, welcome to this week's episode of the Ask the Masters program. I'm Dave Penton from Fluid Dynamics, and today in studio we have Peter from Current Systems, but most of you know Current Systems as the manufacturer and the parent company of Riverflow. And so can you introduce yourself today, Peter? We've known each other for many years, but introduce yourself to the listeners.
Yeah, good to see you, Dave. Yeah, I'm the president of Current Systems, as you said, the parent company of Riverflow. We have been in business about 15 years as Riverflow. Prior to that, I started under another company name with a different current generating machine, quite similar, but was the predecessor to the Riverflow.
Okay. And where are you guys located at? You're right here in California. You drove down this morning. Nice 3-hour drive for, what is it, about 75, 80 miles for 3 hours?
Yeah.
Welcome to LA.
Thank you. Yeah, we're from Ventura, California.
Okay.
Happily, I had full autopilot in my car, so I was able to relax a little bit with the traffic. But so Ventura's a small coastal town north of LA. We do our manufacturing there. Our R&D facility is there. Test tank and equipment to establish different performance parameters for the pump.
Yeah, a little bit of a mad scientist kind of portion of your area, isn't it? With your test pool, and you're always kind of testing some new stuff and everything up there.
We are. It's my playpen, since I don't have the training or intelligence of David Peterson. I kind of rely.
Who does?
I kind of rely on hit and miss, and we do a lot of experimentation, observation, recording, and move through the process in that way. And Dave is sometimes quite helpful with theoretical, and then we end up trying to prove out. Achieve our goals or the goals of customers that ask us to get somewhat custom with how we can shape current.
Cool. I want to get to know a little bit about you. So kind of give me a little bit of your background, wife and kids, kind of where you grew up. Did you grow up in Ventura? How'd you end up, where you're at this point?
Yeah, single guy. I was actually born in Orange County.
Oh, wow.
And moved to Northern California when I was a wee kid. And kind of much a California guy, pretty much. I went to the war in the 60s and came back, and I ended up traveling several years of world travel. I got back to, I've lived all over California and kind of wound up in Malibu, and where I got fascinated with current, water current, and built a plywood test tank in the carport, and hooked up a radiator fan and baffles and false walls, and started to observe how current worked.
Wow, that's really cool.
And and so I was fascinated by that, and ended up patenting the pump, what's now the Riverflow pump, in the late 80s. And so the fascination with the current was moved into observing people in current. I don't know if you remember Marcus Allen. Marcus Allen lived in a condo in West LA, and I took a prototype of my pump and put it in the condo swimming pool, and Marcus started working out against the current. And he was so enthusiastic about the resistance and that it inspired me to further develop the current.
So was that just was he swimming against it or walking against it, or what was he doing? That's interesting. That's a really cool story.
Well, he was the water depth was about 3.5 feet.
Okay.
Maybe up to 4 feet, and he was jogging into the current, and then he'd go sideways into the current, and he'd go backwards into the current, and he was just a huge smile on his face, and then he'd get serious, and he'd set goals for himself and try to overcome the resistance. And the first time he really gave it full out energy against the current. I remember he took a big breath and he turned to me and he said, "This thing kicked my ass."
That's awesome.
So the interface there, first it was fascination with the current, and then it was fascination with how people interact with the current and the things that they want to do in it. And so that was kind of the beginning of the whole thing.
So I want to back up. How did you get connected with Marcus Allen? Because he's not a nobody in the sports world. I mean, that's like a superstar athlete, especially here in LA. I mean, he's how'd you connect there?
Well, my partner's mother lived in the same condominium complex that Marcus did in Brentwood, and that was the connection.
Okay, wow, that's really cool. That's fun. So, so how did you then? What were you doing before that? Was that just kind of your inventor style that you had? I mean, were you working in aquatics or in water at that point, or what were you doing prior to that, after the war and things like that?
I was not. I was kind of looking for something to get interested in, and this got my attention. And the things that sort of combined, in the beginning, the application was to come up with a really good swim and exercise and therapy current. And the things that were going on at that time were a drought, of course, in Southern California. Developers were building on smaller lots, and swimming pools were getting smaller and too small to do laps in.
Sure.
And I read Airplane magazine on endless pools back at that time. And they had their 15-foot vinyl liner tank, and that looked like a cool thing to do. And then there were jets so here we are 30 years later or so, and they're still endless, and there's still jets, and then there's us. So I was involved in the redwood hot tub industry. I was a deck builder and a hot tub cooperer in Carmel.
So does that mean creating copper hot tubs? I've never heard that term.
Coopering a barrel or a tub is building the barrel.
Okay.
Like a wine keg, same thing. You have staves. Staves for the floor and staves for the uprights and the hoops that tighten it all together.
We actually just did in Brentwood. We just did a wood soaking tub that didn't have jets, but it had hot water.
Right.
It was fascinating to me. I had never done that. It's a really cool aesthetic. I'll have to pick your brain off air on that, because that's something that I'm fascinated by.
Yeah, well, we're all fascinated with water. That's our industry. And my little niche has become more about current and its various applications and its and how people react to current while they're in the water.
Sure.
And so.
Okay. So we touched on it a little bit, but as far as kind of the industry talks about swim jets, and that's kind of the generic term. And I know you really push back against that a little bit. So can you talk about kind of the different technologies and what differentiates between a swim jet and the endless pool, and then what Riverflow does, just kind of to spell out all of the different options that are available in the industry?
Yeah, well, Jets are basically a jacuzzi jet, the jet you'd find in a hot tub with some more horsepower behind it. And it's very high pressure, aerated, turbulent flow, designed to relax muscles and give yourself an aquatic massage for muscles. How it became named swim jet is still, a bit of a mystery. But in my opinion, it's not the proper way to generate a current to exercise or swim against. Centrifugal pumps are at the opposite end of the pump world than axial flow pumps that we use. We create a very high volume, low pressure stream of water, variable speed, without any bubbles, and very close to laminar flow.
Mm-hmm.
And then the Endless, who's been around forever, is more or less a fan in a box, not really a pump, but it creates a great current. But the limitations are that it has to live in the swimming pool with you, the pump and the hydraulics and whatnot. And you're required to swim up within inches of the outlet.
Oh, interesting. Okay.
And I designed ours so that the current develops a few feet back. So you'll have a sweet spot that begins a few feet from the wall of the pool where the current's originating, and then back 15, 20, 30 feet. Not so with the Endless.
So just to summarize a little bit, so there's a number of manufacturers of swim jets, and typically they're, like you said, they're spa jets, but they're on steroids. I mean, they're larger than spa jets, and they have a lot of high pressure flow behind them, and so they generate pressure. They generate a resistance point that does push you away just by simple nature of the amount of water they're pushing through a small orifice nozzle, and that's aerated. What's always intrigued me about that is, I've grown up surfing, and when you catch a wave and you get all the aeration of the water, air and water actually causes you to be less buoyant, so the aeration effect of everything, I would think, I've never swam in a swim jet pool, but I would think the aeration tends to not make you float as much. I would think it would be more cumbersome to swim against, plus the fact that you're swimming against a spa jet. But the benefit to those systems is that they are budget-minded for budget-minded clients. They can be installed, for a lower budget than some of the other systems, but there definitely are limitations. Now, the Endless, that's always been an intriguing one. I was not aware that the Endless was didn't generate the push that yours does. We've done a couple of Riverflow pools, and you have actually pretty specific parameters. A couple of them that we've built have been really small, and the amount of current generated, I think the last one we did was 16 feet long. And you're right.
Mike Rosenthal.
Mm-hmm.
Yeah.
Yep. Yeah. And on that one, literally, when the pump is running at full speed, there's a 1-inch standing wave 16 feet away. I mean, it's pretty. There's definitely a significant amount of water moving there, and so kind of talk about. What's the experience like in swimming in a swim current as opposed to swimming against a swim jet?
Yeah, well, some very different basics. You're right. Your buoyancy is impacted in aerated water, like the Bermuda Triangle. So you become less buoyant, and you're struggling to maintain your position close to the surface. So in a jetted system, the aerated current is moving, let's say, 30 miles an hour. And it's creating resistance in a focused and small area that you're exerting against. So you have very high velocity environment that's aerated, that's reducing your buoyancy.
And it's also very pinpoint too, isn't it?
Pinpoint as well. So it isn't an ideal environment for swimming. My concept is that, and endless somewhat the same, is that we try to match the current speed, the water speed, to the speed that the swimmer would be achieving in static water. So if a swimmer's going flat out 6 miles an hour, you want the current to be right about 6 miles an hour.
Yeah, even Michael Phelps is not doing 30.
Right. And that is, it's not really apples to apples. It's just an unpleasant environment to try to exercise in. So that's one of the reasons that I chose kind of the axial flow pump road, was to be able to have sufficient volume of water at a low speed matching the output of the swimmer, rather than being in a torrent and trying to survive.
Sure. So, my clients tend to build these big, beautiful pools, and so the aesthetic side of it is always, something that comes into play. And one of the nice benefits of the swim jet is that you can get them color matched, and they can be small, and the impact within the pool is not that significant, and yours as well. Your system can be mounted to the wall. It is one of the challenges with the endless pool system is that you have the stainless steel box, and I've seen some very nice ways that architects have been able to integrate that within there. But I think that's one of the benefits of both your system and and a swim jet system on the aesthetic side, is that the visual impact to the entire space is definitely limited. And I know you have the ability to really kind of fine-tune and customize some of that as well, correct?
Correct, yes. Yeah, our wall penetration, our wall fittings are flush with plaster, and they don't protrude into the pool as some others do. So it's less of a challenge, certainly, for architects and to disguise. Our system runs at a max of 58 dB, which is softer than our conversation right now.
Yeah, it's not very loud at all.
And you really don't hear it from 5 or 10 feet away. The more powerful jetted systems are quite noisy, as well as endless, because it's a high pressure hydraulic motor run by a hydraulic pump. And those two elements of that system make it noise is a consideration.
Okay.
So we've tried to make ours as silent as possible, and it's very, very quiet.
Yeah, I can attest to that. The first one that we did, we had a very large decorative wall at the end of the spa, and literally the pump was sitting 20 inches from the water. Though it was behind a wall and you couldn't see it, and yeah, even with it running at full speed, you could barely tell it was there. So that is one of the wonderful things, and it's sort of like variable speed filtration pump technology too. Those pumps have gotten very, very quiet, and so that's explain how in the systems you moderate the flow and all of that. It's not all on or all off. These systems you can turn the flow up and down as needed. So get into a little bit of that.
Yeah, we use variable frequency drives and have been for 25 years to control the pump, and in recent years, like last 10 years or so, I think Penton was the next to come on board with variable frequency drive technology, and it's a great way to control a motor. So one of the benefits of using a variable frequency drive to reduce the speed of a centrifugal or axial flow pump is that by reducing the speed of the pump by 20%, you reduce the electrical consumption by 50%.
Mm-hmm.
So in larger commercial projects, I try to design to running the systems at 80% capacity so that their savings are huge annually on a multi-pump project. And they have plenty of power. They can always have more gas pedal if they want it for certain situations. But we try to be consistent with the new and improved hydraulic design requirements with sweep elbows and things. The industry's come a long ways in just the last few years by reducing electrical consumption. And we've always been on board with that.
Sure. It just makes a lot of sense. I mean, it's definitely, it's been a long time coming. You know, we happen to live here in California where we kind of pioneer a lot of this. But, you know, at the end of the day, you know, we're not, everything's not endless, you know, and the more we can reduce our footprints, you know, whether you have an environmental, you know, bent to yourself or not, you know, everybody enjoys having a smaller electric bill, you know, so the practical aspects of it, you know, are beneficial to everybody. That's been one of the things I've really enjoyed watching the maturity of the pool industry in that whole area. So I know we've been focused quite a bit on swim jets and swim currents, but that's not the entirety. There's this whole new emerging thing. You guys have been doing it for a long time, but there's a whole emerging lazy rivers and all of that really seems to be kind of catching fire in the last 2 to 4 years, and so. You know, talk a little bit about the technology, what it is, how does it work, you know, even in general terms, how is a lazy river work, because they're fairly tricky, and can you just kind of explain just generally the hydraulics of it and what needs to happen for a lazy river to flow properly? It's not just sticking a bunch of pumps in a wall and turning them on. There's a whole lot more science and hydrology to it.
Yeah, right. It's a great new trend for us because, and I feel like we've been somewhat instrumental in developing that on a residential basis. People travel more, go to resorts that have a lazy river, and they come home and call their designer, architect, pool builder, hey, can you shrink that down and put it in my backyard? So the challenges are making it operate like it should and not just throwing a bunch of or pool pumps at it. Happily, the Riverflow pump turns out is ideal for that application, and we've probably done now 60 or 70 residential lazy rivers in the States, and we have a pretty large international presence with resorts and water parks and focusing on lazy rivers. We've developed several different types of nozzles to shape the water in a way that the project requires. So we like to work in the 2,000 gallon per minute range at discharge velocities of 15 to 18 feet per second. So that's a fairly substantial volume at quite a high velocity, but what happens is that the plume, if you will, of energy, as it travels along the river, is dissolved into the river, and the average speed of the river will prevail. So you'll have a little faster area closer to the pump, but it's not going to slow down and slow down and slow down until it gets to the next pump. That seems to be a common misnomer. What happens is you've established a steady state or an average speed. So actually one large nozzle in one location can power a river, and you're not going to have a tremendous drop-off in velocity as the water returns around to the origin of the motivation again.
Yeah, I remember growing up, and my grandparents had a spa. It was just a 7-foot round spa, and me and my brother, we'd start that thing spinning. And not even with the jets on. We'd just get in there and start it spinning, and then we could just stop and float, and we would just bang into each other and everything, but we would float on our backs. And it would keep going and going and going and going and going for a while. It doesn't need to be. So it sounds like it's kind of the same concept, is that once you get it engaged and you get the water moving, so answer me this: when you turn that pump off, I imagine that it takes a little while for the river to actually stop spinning.
It does. It takes longer for it to stop spinning if your rotation direction is counterclockwise
in the northern
hemisphere. But we've done with this residential pool thing, an interesting design is developed. That we've developed a manifold of nozzles that I call a water curtain, and we're able to move water around a river, around an island. And then one of our water curtain nozzles keeps the water moving across an open pool.
Oh, interesting.
So we can leave an open area of water common to the river, but relatively calm without current.
So almost like an island of non-moving water in the center of the pool.
Yeah.
Wow. That's fascinating.
Yes, so we've been. Those are the things that get our attention, and we're of course aided by the ability to, with our test tank, to dial in.
I was going to say that's why I was just going to bring it back to. I mean, now your mad scientist back at the warehouse is all starting to make more sense.
Right.
We interrupt our program to bring you this important message.
I'm joined by Peter from Current Systems, the parent company of Riverflow. You create something completely unique in the industry like nothing else. The Riverflow system is completely differentiated, and in my opinion, I think it is the best option for swimming within the industry. Tell me a little bit about your system and what differentiates you from the competition.
You're going to get a very enthusiastic referral from your happy customer. Is a good reason to use a Riverflow. The system is a very high volume, very low pressure pumping system that uses 12-inch diameter pipe.
That's a big pipe in a swimming pool.
Big pipe. You can't move big water through small pipe.
Sure.
So we have part of our system are dual VGB approved suction grates and sumps. 2 of those with each pump. Industrial 3-phase motor, variable frequency drive, wireless remote control, and specialty accelerator nozzle or manifold or whatever your application requires for configuring the current, return current.
So the 2 big applications for Riverflow are going to be your swim current system, where you can convert a pool as small as, I think the smallest one we've done is 10 by 16, and you can make an actual exercise pool where a client can swim. The client that we had, he was actually a competitive swimmer in college, and he utilized it every day as swimming.
Infinite speed control, not just a couple of presets, but actual speed control, so that they can adjust the current, the feature, the swim current speed, whatever the application might be. They can dial it in, fine tune it.
But then you also are really one of the innovators of lazy rivers.
We're enjoying the popularity of the lazy rivers and doing what we can to innovate and combine a river and a pool, island and a bridge, a kayak lane, and a beach entry. All of those things can be features within one pool project, which opens the door to some very creative and compelling designs by architects. Our personal attention to every project is nothing but a bonus, and we can have a positive influence on the results. So, yeah, we're more hands-on certainly than most.
The beauty of your system is that it does not need to be 75 feet away. Your system is very, very quiet. It's one of the things that I really love about it. It allows for some real creative versatility in that we're not having to worry about the noise pollution by just the way you've designed the system.
More often than not, the Riverflow system isn't installed with the rest of the pool equipment. It's located in a hydraulically more friendly location, so we can avoid losses and added expense. It's one of the nice features about the system is that from a few feet away, you don't even know it's running.
I heard rumor that you are working with dolphins.
It's been a pleasure to work with the Clearwater Marine Rescue Aquarium in Clearwater, Florida. Winter, the Disney dolphin, lives there, and now Hope, Winter's companion. And a few years ago, we donated a couple of pumps to create a current in their large saltwater tank. According to the trainers and the veterinarians, the general health of the dolphins skyrocketed. Their attitude, their happiness factor went up because they're pre-wired for that kind of environment. Sure. And so it was very rewarding to work with them and to learn from them. The other thing that was interesting was that saltwater environment had no detrimental effect on our equipment. So we're good with chlorinated, salt, any seawater even.
You can create within one body of water very different environments for the client, and it really allows the pool to become so much more versatile than just a cooling off hole in the backyard. I think you're developing a different style of nozzle now with a whitewater type of a nozzle.
The wow factor, kids usually is what's driving that development. It doesn't have to be either or, static or dynamic. It can be both. We've learned how to integrate our current systems even with vanishing edge pools. It's just doing the math and making sure that you have sufficient overflow capacity, catch basin, but at the flick of a button you can turn that vanishing edge piece of glass into a completely different entity that's all about motion and energy and it feels different and it serves a different purpose, and then you can turn it off and finish your martini.
We return you now to your regularly scheduled program.
Yeah. One of my early models and early patented models of the Riverflow was over the side model,
okay.
And similar to what Endless has come up with.
Sure.
More recently with their Fastlane product.
Okay.
But it was cumbersome and laid across the deck, and it turned out to be not really practical. But it was what was inspiring to move forward past that point was I was able to donate one of those over-the-side units to the VA hospital in Sepulveda.
Oh, wow.
And which was later wrecked by an earthquake. But so I worked with their physical therapists, and we put it in this big 20 by 40 indoor pool, and we'd get the whole pool rotating like a big whirlpool. And then they would bring in the paraplegics and quadriplegic veterans that had a fairly dismal existence.
Sure.
And whether they were in recovery or just permanently there. And to see them light up
Oh gosh,
in
I
the
can
current.
imagine.
So the hidden benefit was not just to put them in a static pool in flotation devices, but when the current was on, they'd light up with this. They would have to do something. There was exercise that just happened. and motion that happened. And it was it was a delight for them and for the therapists, and it kind of opened a new window of understanding that just being in the current, it compels you to interact with it.
Well, and I would imagine somebody like that who's confined to a wheelchair and really, to be able to be free again, just to be floating and not, constrained to, maybe even having to be strapped in because you don't have the ability, just to be able to be free again. And I can see the benefit of that. That's a really cool, amazing story.
It was moving, and it was so what it inspired in me was the benefit's obvious for these guys, and I became more interested then in therapy applications, and just in people interacting with current, and it's a different reaction to current than it is to just static water.
And the other benefit too of just exercise in water, as opposed to running, is that it's virtually no impact. I mean, it's such a my stepdad is an orthopedic surgeon, and he said the best therapy for surgery is to be getting in a pool, because you can exercise, you can move, you can do everything, yet you're not creating that jarring impact on your joints and everything. So so talk a little bit more. I know we touched about it a little bit. Where are you seeing all of these systems kind of fitting in as far as the fitness and exercise and health benefits and all of that? Where are you seeing these applications being installed? Obviously the Marcus Allen story is cool, but that was 30 plus years ago. What's kind of the latest generation that you're seeing these implemented?
Yeah, I think recreational, health while having recreation seems to be...
And fun,
very popular. And the lazy rivers, one of the cool things about a lazy river combination pool is that we can establish a current that's swimmable, or you can kayak against it, or you can float around in an inner tube with a martini in it. You can hop out of the current and do whatever you want to do in still water, while kind of having fun.
Mm-hmm.
It's probably the world's best babysitter to have a current.
Next to a trampoline. I have a trampoline in my backyard. That's a pretty good babysitter too. But yeah, I could see that.
Yeah. So we're finding just so much excitement. A lot of Toyota moments when people first turn on their river, and combining that, that environment with an exercise environment, a fun environment, a beautiful environment, peaceful. So versatility, it's people are getting it that, man, it doesn't have to just be the conventional pool.
Mm-hmm.
It can have drama. It can have, it can be compelling. It can have a lot more aspects than just a static pool.
So I love that analogy that you can have a single body of water that is able to provide 3 and 4 different environments. It can be, the lazy river analogy is great. Yeah, you can be Marcus Allen and training to be the greatest, one of the greatest players in the NFL, and yet in the same body of water, in the same everything, you can be sitting on a float tube and reading a book and fall asleep. It's really, that's an intriguing thing that I hadn't really thought about. One of the benefits of being able to morph your pool into all of these different personalities, if you will, and not have to go to the resort where they've got the dedicated lazy river, and then they've got the jacuzzi tub, and they've got and then the long 80-foot long swim pool for lap swimming, and that being able to create all of those different environments within one entity that will fit in a traditional backyard. That's an amazing benefit.
Yeah, I think you just nailed it. Yeah, it is. You can. I think when people are designing their pool or working with their pool designer, they often think of them in a lounge chair at sunset, infinity edge. I've arrived. Mm-hmm. Life is wonderful. It's calm and it's peaceful. I think we've been trying to get people to expand that vision to include push this button or click that switch or tell your cell phone, I'd like some current, please. Mm-hmm. And boom, you have a dynamic environment. You have drama. You have the same pool, but it's turned into a completely different animal. And so I think we are able to transform a formerly static, peaceful, environment into something that's got some more drama to it.
Sure.
And exercise lends itself to exercise, and we're finding so much enthusiastic reception by kids. They want to floor it. They want it to go faster. They want it radical. Mm-hmm. We've developed a Whitewater Nozzle. Aside from our basic lazy river nozzles, where we've reconfigured one and angled it upwards, and it comes blasting out through the surface, and it sort of replicates the prop wash from a speedboat. So you've got turbulent white water downstream, and that's been fairly popular. And
I would imagine that over the course of your career, you've seen some really, really cool sites and everything. I know that you're very hands-on, and that you do actually love to get out into the field and look at some of these. Can you talk about some of the more unique applications that you've been a part of? I mean, the creativity of architects and designers is endless, it seems like, and I got to imagine you've seen some pretty mind-blowing sites and applications where you guys have been a part of.
Yeah, the creativity abounds, and it opens a new window for an architect or designer to have moving water. Just different thing altogether. We've worked together with some architects, and we've come up with islands within a river where we plumb underneath and bring one of our nozzles up out of the island. And the island shape can be a foil, like a wing shape. So water encountering the leading edge, if you will, mm-hmm. of the island, and then moving around it in a way that's predetermined by its shape. So, and then having a series of nozzles out the slipstream of the downstream end of the island. Mm-hmm. A lot of creative stuff, a lot of ways to move people in and out of calm areas to get in and out of their inner tubes, or to not spill their martini. We've had it's been very rewarding to work with architects that have been receptive to some of our design modifications to emphasize the hydraulic efficiency of a large project. Most of the designers and architects don't have a hydraulic background.
Sure.
So we enjoy getting involved early on in the project with them, so that it can be tweaked to provide the aesthetic that they want, the performance, and the efficiency. and all of this can be a very extravagant or gorgeous environment, but it's really functioning quite efficiently, or can be.
So it sounds like you're doing a lot of commercial type projects and a lot of the international stuff. I'm assuming that a lot of the international stuff is more commercial water parks and things like that.
Yeah, commercial water parks and resorts. We work with the design engineers that eventually spec us into the projects. We work with them on the hydraulics, and we work with the architects on the design and river geometry and the safety and the access and whatnot. So it's each one is unique, each one's different, and it has become so popular worldwide to have. Lazy River there isn't a theme park without one now.
Sure.
Or resorts. It's almost like the Joneses. And the first resorts started to put in a little gym, a workout area. Well, then they all had to have a workout area. And I think it's kind of like that renovation is going on with smaller hotels, too, to take out their kidney-shaped 1930 swimming pool and put in a little lazy river and put that on their marquee, and their occupancy goes up.
Yeah, I mean, you look at it's one thing that's always been fascinating about swimming pools for me. Residential and commercial and everything. Most of the time when you go look at a hotel, you'll see the front of the hotel, but usually as you start scrolling through the photos, within 2 or 3 or 4 photos, you've got a picture of the pool, and just that water environment. And look at real estate photos. You'll either usually you'll see the architecture of the house, and then oftentimes that second photo is the photo of the backyard pool. It's just such a place where people want to be. One of the things that I love about your guys' system is just that very fact that what you're putting in a resort in Dubai is the same equipment that's going and being sold to the residential client. You guys don't dumb down the system. It's not, there's not a commercial grade system and then the residential grade. It's all the same. You've developed the system to the place where it's not. There's no limitations on the residential retail side. So these things are really set up to run 24/7. Correct?
That's correct. Yeah, we don't distinguish between the residential commercial application. So. They're designed to run 24/7. They're designed to be appropriate for the type of environment, whether it's high altitude or whether it's tropical or whether it's very high temperature like in the Middle East. We tweak the system, the electronics for those environments, special environments, but the pump itself is the same in every instance. The components, the parts that we manufacture, are commercial or residential, it doesn't matter.
You're an American-based company.
Yeah, well, we use electric motors come from South America. The VFDs are manufactured in the States. The props, castings, other components that we don't actually machine and manufacture are made here.
Yeah.
Which more expensive, but it's the quality control is so much easier and more reliable. So yeah, we don't even our shafting, stainless steel shafting, is American made and American machined,
and that's a serious piece of hardware there. It's not a little $30 piece of metal with some set screws in it. That's a heavy duty piece of stainless that you guys use to make your couplings. So is it a propeller? Is it an impeller? What is it actually called? I always get confused.
It can be called either.
Okay.
It's an axial flow pump, which means that the water flow is in the direction of the axis of the propeller. So the water's passing through the propeller, and moving in an axial direction, completely opposite of centrifugal pumps where the water's coming in axially and leaving perpendicular to the axis of the pump. Centrifugal pumps typically run at very high RPM, create a lot of pressure, and use relatively small pipe sizes. Other end of the spectrum, propeller pump, axial flow, very high volume, low pressure.
Yeah, and that's with your systems, we're installing it's 12-inch pipe. It's very large because you're trying to not disrupt that flow, and since it's axial, you can't pass through 1290s. It's got to be it's a very laminar flow, and it's very much generated at the propeller, whatever we're going to call it, point, but you really need to have that kind of a smoothed out as it enters into the pool.
Yeah, right. We can't tolerate a lot of losses through plumbing in 90s, and particularly 90s, close radius 90s are the biggest culprit really in the pool industry for eating up too much energy.
Sure.
So we use sweep fittings, even in 12-inch,
Mm-hmm.
and we try to keep the water moving at a reasonably slow speed through the pipe and let our nozzles do the accelerating when necessary, and reduce losses wherever possible.
So what does your pump generate? You like 1,100 gallons per minute? Where exactly are you at? I know you've got a couple of different, but let's talk about like the competition model, the top of the line. What are you moving as far as actual water movement?
Yeah, our two models, the competition and the elite, are identical except for the size of the motor. One's a 10 horse, one's a 7.5. Our flow rate is about 2,500 gallons per minute. Various nozzles will reduce that by 200 to 300 gallons per minute, which is the capacity of many pumps of the same horsepower.
Sure.
But they're delivering pressure, not capacity or volume. So we're in the 22 to 2,400 GPM range typically through most of our nozzles and manifolds.
Okay, so I have a question for you then, because I've seen some different manufacturers out there talking about 5,000 GPM. So if I'm using 12-inch pipe, and we're safe at 2,000 plus RPM, to be generating 5,000, I don't have my spreadsheet in front of me, but I'm thinking that's 16, 17, 18-inch pipe, and these systems I see are going in a 3-inch pipe. How are they achieving this 5,000 gallons per minute? That just doesn't seem. I think the physics of that just don't work.
You're right, they don't. Yeah, I think those claims are it's just not physically possible to achieve that kind of flow rate through a centrifugal pump using that kind of pipe size. I think what they're leading the public to believe is that the pump is that they're producing 5,000 gallons per minute through the pump, which isn't the case. But the best that I can figure is that they're determining that in a given minute, 5,000 gallons of water must be in motion somehow in that body of water.
Well, by that logic, then your lazy river might be moving 30,000 gallons a minute.
Oh, yeah, at least. Or a
that,
million.
Or exactly.
Yeah.
Yeah. So that seems a little.
In our swimming application, yeah, we'd be at 30 or 40,000. By that, using that same logic, we'd be at 30 or 40,000 gallons per minute. But we chose not to get in that. So the pump curves speak for themselves. If the proof is in the pump curve.
Well, and the hydraulics just don't play that out either. But literally, coming out of your nozzle, you've got 2,000 gallons coming out of the nozzle itself.
Through the pump and out of the nozzle, yeah.
Yeah.
But, we couldn't push 100 gallons per minute through a filter.
Yeah.
So there's an appropriate pump for just about every application. And in my opinion, if you have to doctor the performance numbers so radically to make the pump try to fit into an application, it's not the right pump.
Sure. All right. I feel like we've really covered everything as far as kind of what moving water is. Is there anything that you can kind of let us know you're kind of playing with in your mad scientist laboratory that you're excited about? What are you looking forward to? What's the next innovation you're trying to create or invent, or what are some of the things that you're working on that are unique that have you excited?
Well, we're looking at a couple things I'm not going to talk about quite yet,
Yeah.
but we're having a blast playing with it. No, we're always refining, and trying to up the performance, reduce the operating costs, keep our prices where they are, and keep our quality up. I think the Whitewater Nozzle I'm still refining that and playing with it. I've probably got 5 or 6 different designs out in the field yet that have been installed but not yet brought online, so I'm anxious to visit those sites. Our water curtain technology is always being tweaked so that we can separate moving water from still water in the same vessel. That sort of sounds smoke and mirrors, but it's a real deal, and that's fascinating. So we welcome engineers, architects, builders to come by. And we've considered having group visits. I haven't put anything together yet, but you're certainly welcome, or if you put together a group that would like to come and play and learn and ask questions and just have fun doing some water moving activities, we'd be happy to receive them.
Yeah, and you had mentioned that, and that's really been brewing in my head. I know I personally will take you up on that, but we may have to see if we can get a group of people to come up and kind of just play and understand. And just even, I love the fact that you've got that tank there and that you innovate. I mean, I do that kind of stuff in my back garage, and my son and I play around with different ideas, and I think that's where it's where true innovation happens, and yeah, you're going to have 37 failures for every idea that might or might not ever get fully baked. But it's always, I love that aspect of just life and design in general.
Yeah.
All right. Well, thank you so much for coming. This was I love learning, and even though we've done a couple of your systems now, I'm always fascinated by all the different applications, and I learned so much today too. So thanks for coming in and really educating us and sharing your knowledge with us.
Thanks, Dave. Good to see you again.
Thank you.
All right.
Thanks for listening to the Ask the Masters podcast, and don't forget to check out our Facebook page each week on Tuesdays for new episodes of the show. I also want to encourage you to stop by the Ask the Masters Facebook page and invite other like-minded individuals to join us there as well. Feel free to jump into the conversations and even post your own questions. We want to create a community which fosters learning and discovery for the betterment of us all. You can also subscribe to the podcast on iTunes, Google Play, and Spotify. Please be sure to subscribe and feel free to share.